Explanation of Liouville's inequality in the theory of functions of real variables is incorrect. Liouville's inequality, i.e. Formula 1, is interpreted that there must be a gap of at least 1 of a star times q to the nth power between the irrational x0 and any rational p of q. And a conclusion follows that the algebraic numbers are spotted over the plane like stars against a black sky. The dense blackness is the firmament of the transcendentals. Therefore, the so-called theory of transcendental numbers is seen as the base for Lebesgue's measure theory. The above explanation of Liouville's inequality is incorrect. On the contrary, when q tends to infinity, a star times q to the nth power tends to 0. That is to say, as q increases infinitely, the rational p of q can approach the irrational, or the transcendental, x0 infinitely. In fact, the irrational p of q can approach x0 infinitely regardless of whether x0 is an irrational number, or a rational one, because a star times q to the nth power tends to 0. Of course, the transcendental numbers aren't mentioned in the Liouville's inequality. Can the rational numbers q plus 1 of q to the qth power approximate e? If this approximation is obstructed by a constant quantity, even though this quantity may be tiny, it can't be said that this irrational number is approximated by rational numbers properly. On the contrary, as the formula 2 and 3, where x can be any positive number, i.e., when x tends to infinity, there exists the inequality 4, where epsilon is an arbitrarily small positive number, so it can approximate e perfectly. Actually, even Liouville himself didn't give any rational explanations of Liouville's inequality. In 1844, Liouville pointed out that algebraic numbers can't be approximated by rational numbers perfectly by the function 4, and setting that px and qx equal this, Hermite got the equality 5, where rx equals this. Finally, he got the inequality 6, or this, where q is greater than or equal to c and c is a constant determined by epsilon. If we compare 4 with Dirichlet's inequality, where theta is an arbitrary real number, q is an arbitrarily given real number, which is larger than 1, and both p and q are integers, we will find that the explanation of Liouville's inequality given by the current mathematical world is incorrect, because theta in Dirichlet's inequality can be x0. In Liouville's inequality, the crucial point is that q is set in order to approximate a certain real number, that is to say, q tends to infinity. This series of videos is coming to an end. Finally, let's make a summary. The analytical mathematics, especially the modern analysis, has never been what is comprehended by mathematicians who know little about the mathematical history, and has never been what is written in current mathematical textbooks. Mathematicians represented by Poisson had never been in favor of rationale, the calculus established by mathematicians represented by Cauchy. Moreover, mathematicians represented by Poincaré and F. Klein had never been in favor of the theory of functions of real variables. People seem to have forgotten that Poincaré, Klein and Hilbert were 3 huge figures, standing on the boundary between mathematics in 19th century and mathematics in 20th century. Unbelievably, the so-called theory, which was opposed by 2 of the 3 huge figures, became the mainstream with the support of Hilbert. There must be some reasons outside the mathematics. All in all, some of the demonstrations shown above may not be undefective. However, if one of these demonstrations is tenable, the theory of functions of real variables, which is regarded as a perfection of current rationale, the calculus is bound to be untenable. Speaking of which, friend, you must understand, all the information is listed here, and can be accessed by interested readers.